So in the last lesson, we looked at this constructor, the proto object, and we also talked a little bit about object comparisons, and we also discussed using this instance of keyword. Now in this lesson, we are going to dive into what we would call a constructor function. Now a constructor function allows us to create a new instance of something. Now that's not necessarily to do with the instance of, however, we might want to create the same object, or at least a copy of the object multiple times, and if we update one object, we don't really want it to perhaps affect the other objects. So this is where the idea of instances or unique objects comes into play. Now for this, we're going to get rid of our before console logs. We don't need these anymore. And what we're going to do in this exercise is change our cart over to a constructor function, and then we're going to use the new keyword to instantiate it. The new keyword then allows us to create a new instance. Now at the moment, we've simply got our constant of create cart. Now typically a constructor function will begin with a capital letter. So it might be that in your JavaScript past, you've done something like this and you've initialized a new array. It could be a new string, it could be a new Boolean, it could be a vast amount of different things. But essentially these are the built-in utilities in JavaScript. Now in JavaScript, we can also create our own objects that are then what we would call newable, in a sense that we can create a new instance of them. So typically it would look like this, where we have a capital C and we would initialize a new instance of this cart. Anything we then do to the cart, such as adding or removing perhaps, then applies to that specific instance of the cart because we have called this new keyword. Now the new keyword we need to use with a constructor function, and at the moment this is simply a create cart variable which holds the value of an arrow function that simply returns us an object literal. So what we're going to do is move away from this object literal approach, and I've deliberately began this course, or at least this chapter of this course, is object-oriented programming, by talking about the real basic objects. So now we're going to start diving, now that we've covered prototypes and this idea of inheriting things from elsewhere, we're now going to refactor our create cart factory into a constructor function, which means that we can then call new cart. So let's go ahead. What we'll do, instead of a constant of create cart, we're going to start off with a function called cart. Now it's not going to be an arrow function, and we also don't need these brackets. So this is going to be a normal function cart. It will accept the items if we want to initialize our cart with some particular items. Now, because we are using a constructor function, there are a few interesting things that can happen here. Now, because functions are in fact a special kind of object, we can actually add properties to an object. So we could say cart.name if we like, and we could say something like my cart. So that's perfectly valid JavaScript. Now it might be before you've seen something like this, where we would say cart.prototype.name, for example, and we can start assigning methods or properties to this prototype object. So when we are in fact creating our own custom constructor functions, it might be that we start adding properties to the prototype if we want them to be available and inherited through each instance of our cart. Now we don't need to worry about that. Let's go ahead and finish off our constructor function. Now you may be thinking as well, why aren't we using ES6 classes or ES 2015 classes? And we're going to be converting this older style constructor function over to a class momentarily in the next couple of videos and talking about the differences between them. Now because we are inside a function, we no longer have an object literal, which means that we need to start talking to our this keyword. Now, though this keyword does in fact mean that we're directly storing this item on the cart. So it could be cart.items. That is exactly what we're going to get here from doing this and then calling our new cart. Similarly, if we go and do something like this, we need to bind the method name. So here we can say this.add and this.remove, and we can then turn these into arrow functions if we like, or just use a regular function. However, because we are inside an arrow function, the this keyword will point to the this keyword inside of here. So it doesn't really make any difference in this case. Now we don't need our commas here. These are going to be semicolons as we got on line 4 at the end. So we're not using object literals, we are using properties and we're declaring properties on our cart object. So let's go ahead and save it out. Now, first off, when we were doing this before, we could see the object here, but now we've got a name before it. So you can see that we have this cart. So immediately we can debug our own code in an object-oriented fashion, and we can start to see what objects we're dealing with. So that's one really handy thing. Now, in the last video, we looked at something like this, where we say, is the cart an instance of our cart? What I'll also do is just get rid of these as well so we can clean up our logs. Now you can see that we do have a true result. So our cart, where we have here, is a brand new instance of our cart, which is our constructor function above. And essentially, this is the exact same in ES 2015 classes with the new class keyword. However, the class keyword is more syntactic sugar, and we also like to use it with things like TypeScript as well. So before we go any further, what's really interesting that's happening here, if we undo some of these changes. So now what's really interesting, if we say cart.items and have a look at what we're getting. So here we are adding that particular item. We then log out the items, which means that we do have one item in our cart array. So this is great. However, there's one interesting thing that's happening here. Let's get rid of our items and just have a look at our cart. So let's expand it. We now have our add method. We have our items, that property, which is just our frozen array. And we also have a function to remove items from the cart. So do you think we're finished here? Not necessarily. So let's assume that taking our previous example where we're potentially going to have multiple carts. So let's say we want 50 different carts, for example. We could go ahead and just start creating all these new instances, and each one will then go ahead and work independently. So this is super. Now, the reason they work independently is because we are initializing those item values in the constructor. Now, what this also means is that every time we do, in fact, go and create a new cart instant, we're declaring these add and remove functions every single time, which when we're dealing with big objects or data structures, the most efficient way would be to inherit these methods from the prototype. So this is why we're digging into these constructor functions first to understand how they tie in with this proto and the prototype keyword. We can already see that we have a proto of an object here because our object does in fact inherit from JavaScript objects because we have this constructor, has own property, and 2 strings. So we know all this, we've seen this before. This makes total sense to us now. So the piece that we do want to do, instead of using these up here, we're just going to leave these 2 more configurable. So you can treat this as your constructor function. And when we want to share methods, we would do so by opting to use the prototype. So when we move things out, instead of this.add, we would in fact use cart.prototype.add. So this is then going to add this method to our cart's prototype. So if I go and do this again below, now if we were to save this, this would give us a massive error. Can you think why? If you can guess why, it's because of the this keyword. Now that we've moved our function outside of the constructor, our arrow function is trying to access this when arrow functions don't have a this context. So we need to actually go and fix this up. We can do that quite easily by changing this to just an anonymous function that is not an arrow. Similarly, we can do the same below and rid our arrow function here. It's absolutely fine to leave arrows inside of here. So when we save this out again, we can now see that our cart has our items, but there's no add or remove that we could see before. However, if we open our proto, yes, it has object, but if we expand it further, we can see that the constructor was from the cart, and it also has our add and remove prototype methods. So these are inherited right away from our cart, which means that if we were to create perhaps 4 different instances and we start manipulating them, these add and remove methods are only going to be created one time, which is really, really good for performance. Now, a lot of us, I think, started off with jQuery. And then when you use jQuery's $, for example, and we could do something like my-class, what we're in fact doing here is spinning up a new jQuery object. So this is a real-world example of object-oriented programming in practice. And what can you do with jQuery? We can do things like add class. And it's very efficient for jQuery to inherit all of the methods. Think about the hundreds of utility functions that would come with jQuery, from adding classes to event listeners. They all inherit these on the jQuery prototype. If you want to dig a bit further into that, I would go and have a look at it in your own time. We're not going to cover it in this lesson. But that gives you a real world idea of how things work. Now, what I want to do is just reiterate. So what we've got here is a new call to our cart. We're not passing in any items to initialize, which means that our items can be safely initialized as a new array. Now you'll see here that we're using our good old object.freeze to ensure that immutability. No one's going to mutate our items array. And again, every time that we mutate, we're using an immutable pattern and then freezing it upon reassignment. When we had our add and remove functions inside of here, they are called local properties, and they are not accessible on this proto object. So anything that we can see in this proto, we can just simply log out and inspect it in the browser. And anything that we add, such as our cart.prototype add, cart prototype remove, will then go and exist on our prototype. Now there is also one other flavor which you could use to adding things to the prototype. I've seen this before. I wouldn't necessarily recommend it, but it may be a question that you do have. So it may be that we do something like this, and whether you've seen this before, you are declaring a new prototype of our cart. So at this point, we could then say add, and we could pass in a function. We could do the same with remove. However, to set the correct constructor, we would have to go in and manually set it to cart. So this is an easy way to get things wrong. If we were to, for instance, leave out this constructor, it could play a bit of havoc with our instance of operator. So ideally, we don't want to do that, but I'm going to answer that question if you've perhaps thought it or were thinking it. So this gives us a really nice setup when we want to now move to ES 2015 classes, which also compile down to exactly this. If, for example, we are using Babel, which we are in our project, we are compiling down to ES5. That's not to say that some of these features do not exist in the browsers. We just know that we're getting a full feature set when we compile from ES 2015 down to an older version of JavaScript, because some older browsers do not support ES 2015 classes, so this constructor function approach is what they would be essentially compiled down to. So that's it for this video. What we've done is take our create cart factory function. We've then removed our factory function and changed this over to a cart constructor function. We've talked briefly about the uppercase first letter. This is typically something that you'll see around a lot of code bases to denote that this is a constructor. So this is a pattern that people use, and I would highly recommend that you also follow the same pattern. We don't want to override the entire prototype of an object, so by accessing the prototype and simply creating .add or .remove and then assigning a value allows us to then extend our custom objects without interfering with anything such as our object, which we are definitely inheriting from as well, even though our object is a custom cart object. So hopefully this gives you some nice information on prototypes. I think this is really useful for us to understand. Now, in the next few lessons, what we're going to do is move this again into ES 2015, the modern ways of doing things. And I'm also going to show you how we can use some brand new features, some private fields on ES 2015 classes, as well as some really nice ways to handle this object freezing with setters and getters. So this is my favorite part that's coming up, and I'll see you in the next couple of videos.